Here we will be examining the HP40-145A semiconductor analyzer. In this series we will be restoring a unit with a number of issues including a poor display, power supply restoration and the lack of system software. In this first part of the series we will be replacing the unsupported floppy disk drive with a suitable SD card unit, and provide the missing software vital to the operation of the unit. Let's fire the unit up for the first time. Hit the power button, ensure nothing is connected to any terminals. We note all the LEDs flash on the keyboard. This is a good sign. We note the display shows the error M02. Let's take a look at the service manual to diagnose the error code. Open Operating and Service Manual. Go to Section 8, Service. Open Section, Troubleshooting. Take a look at Table 8-1, Hardware-related error codes. We see at the bottom of the table the error code M02. It states, floppy disk drive signal was not detected. Since the 4145A requires the system software to be loaded from the floppy drive, the system is unable to fully boot up. This unit was built in 1985. Like many of these machines, the system software floppy disk has degraded to the point where it is unable to be read. We must consider swapping out the floppy disk drive, and replace it with a more reliable modern form of media such as an SD card. Before we decide on a suitable replacement for the floppy drive, let's take a look at the drive currently installed. Unplug the unit. Place it on its right side. Remove the bottom cover. Unlatch the ribbon cable and remove the 4 screws securing the floppy drive to the chassis. We can now gently slide the drive forward. Remove the ribbon cable from the drive. Slide the drive all the way out. Now unplug the drive power cable. This will require a little jiggling to release. With the power cable unplugged, let's examine the drive. It's labeled as a Canon MDD 6106. Here are some high-def pictures of the unit. Let's first determine the disk format used by the unit. Open Operating and Service Manual. Go to Section 1, Description. Paragraph 1-8. We note the disk is single-sided. 92 KB disk. Go to Section 5, MSU Diagnostics Mode. Paragraph 5-45. We note the disk has 40 tracks. 9 sectors. 256 bytes per sector. That gives us around 92 K. This matches what we read earlier. Let's now turn our attention to the drive. Although labeled as a Canon, the drive is actually a BASF 6106 single-headed drive. You can download the technical manual from our companion GitHub site at github.com/exclusively hp/4145a. Let's open this manual and find the specifications for the drive. Go to Section 1-4. We note the single density transfer rate is 125 kbits per second. The rotational speed is 300 revolutions per minute. The encoding is frequency modulation. Go to Section 1.8.1.2. Interestingly, this example matches the format given in the 4145A service manual. Let's now look at the physical configuration. Go to Section 3, Installation and Operation. Go to Section 3.1.4.1, DC connector. This connector is fairly standard, with both 5 and 12 volt supplies. The pinout is standard also. Go down to Figure 3-3, the interconnecting diagram. It's a 34-pin connector, fairly standard for a floppy drive. One thing of concern here is the ready signal is on pin 6, the ready signal is usually on pin 34. Pin 34 is the disk in use signal. We need to check the drive configuration to see if this will work. Go to section 3.1.7.1, select Options. If we compare this to the drive we removed, we note JJ1 is jumped for drive 1 select. That seems okay, since we only have a single drive. Go to section 3.1.7.2, Head Load Options. If we compare this to our drive, we note JJ2 is jumped for auto head load. That seems okay. On to section 3.1.7.3, In Use and Disk Change Options. If we compare this to our drive, both these options are disabled. These determine the use of pin 34, but with both options disabled, pin 34 will be unused. As mentioned earlier, the standard interface delivers the ready signal on pin 34, but our 4145A controller will be expecting it on pin 6. We will need to consider this when selecting a replacement. Let's take a look at the schematic for the A9 board. This is the MSU control board. Looking at the floppy adapter interface, we confirm the controller is expecting the ready signal on pin 6. It's connected directly to U3 ready pin. This is the floppy disk controller ICMB8866. After a fair bit of research finding a suitable SD card drive to replace our floppy drive, we have decided to go with the HXC floppy emulator design by Jean-François. We have chosen this design as it is open and very flexible. Let's look at the specifications. It will support read and write in FM with 256 bytes per sector single density. Supports read and write at 125 kbits per second. Supports 300 RPM. Supports 40 tracks. Let's check out the schematic. As expected, pin 6 is disconnected. Pin 34 provides the ready signal. After discussing this issue with Jean-François, we have come to the conclusion that we will need to modify the board in order to provide the ready signal on pin 6. We have also spoken with Lotharic, the company that produces the product. They have agreed to look at providing a mod in the future. Here is the package as delivered from Lotharic. Delivery was fast and was adequately packaged. We have chosen the revision F mounted in a case, as we intend on mounting the unit in place of the existing floppy drive. We have designed a bracket to mount the HXC directly into the 4145A, and a faceplate to mount over the HXC. Feel free to download and print these models from our companion site mentioned earlier. Hot off the printer we have the bracket. Remove all the support material. Clean out mounting holes with a 3mm drill bit. Insert 4 3mm nuts into the bracket. Mount the HXC using 4 3mm by 8mm bolts. Mount the faceplate over the HXC onto the bracket. Be careful not to strip the holes. Use a nut to set the correct depth on these so as not to protrude through the front of the plate. We will need to splice a 34-pin IDC connector onto the existing ribbon cable in order to connect our HXC. Mark a square line on the ribbon cable 50 mm up from the existing connector, with the existing ribbon connector facing downwards. Place the new IDC connector underneath the ribbon cable, ensuring the notch is directed back toward the unit. Place the IDC cover over the top of the ribbon cable, whilst keeping the new connector parallel to the existing connector. Place the IDC connector into the soft jaws of a small vise. Using sufficient force, close up the vise jaws to point where the IDC has completely closed up. Let's make the modification to the HXC so that it will deliver the ready signal on pin 6. Cut pin 34, on the vertical just before it bends at 90 degrees. Remove the pin completely from the header. Solder a piece of tinned wire onto pin 6 of the header. Shape the wire so that it reaches pin 34. Slip on a piece of heat shrink. Trim to length. Tin and solder onto pin 34. Shape the wire nicely. Place a metal shield behind the wire to protect the board. Use a heat gun to shrink the heat shrink. This completes the HXC modification. Obtain a standard floppy power connector, known as a Berg or mini Molex to 4-pin Molex connector. These have a female mini Molex or Berg connector at one end. and a 4-pin male PC power molex at the other end. The pinout is standard. Plug the male end into the existing power connector. Feed power cable and the ribbon cable through the front opening. Connect the ribbon cable with the notch of the connector facing downward with respect to the HXC. Ensure it's seated fully. Now connect the mini molex with the notch facing downward. Slide the HXC fully into the unit. Secure the HXC using 4 3mm bolts. Stretch the ribbon cable backwards. Secure to the retaining clamp with a cable tie. Place another tie around the HXC power cable to ensure it stays put. Replace the covers and we are done with the hardware upgrade. Let's now turn our attention to preparing the operating software. We will show you how to prepare an SD card under Windows operating system, but other systems are supported. Obtain a 32 GB SD card and format as a FAT32 disk. Most SD cards are pre-formatted already. Place it in your SD card drive on your PC. Go to our companion GitHub site at exclusively HP. Under the 4145A folder you will find the disk subfolder. Download the disk image file and drag it onto your SD card drive to copy it. Do the same for the HXC configuration file. Before we eject the disk, let's take a quick look at the image. This step is not required to prepare the image, but is interesting to see what Jean-François has developed. Go to the HXC website at hxc2001.com. Under Downloads, scroll down to Software. Download the HXC emulator zip file. Once downloaded, open up the zip file. Locate the Windows emulator executable and execute it. Now drag the disk image onto the emulator application. You will notice it loading the image. 40 tracks single-sided. Open the track analyzer. You can now see the contents of the image. One track at a time. Each vertical bar represents a sector. As you drag your mouse across each sector, the data is reported on the top right-hand side. Each sector is 256 bytes. Using the track slider we can select each of the 40 tracks on the image. We can also look at a graphical representation of the image. Change the track view to 48 tracks per inch. This is the specification of our single density image. You can see the layout of the disk. Each ring representing the 40 tracks. And each of the 9 sectors. Jean-François has done a great job supporting with this software and emulator design. This completes the boot software preparation. Time to see if our new drive works. Insert the SD card into the 4145A, and hit the power button. Looks good so far, the HXC lights up. We see our boot image loading and counting through the tracks and sectors. Yes, the menu has loaded. The display is a little dim and needs adjustment. We will cover tuning the display in another clip. Let's check out the software. Hit the extension Softkey. Then Diagnostics. We note the revision and date code as expected. Let's now perform a self-test. Looks good, no errors are reported on the screen. Perform a graphics test. This is as expected also, besides the skewed screen needing alignment. Let's now ensure we can write to the SD card. From the main menu, go to Source Setup. Press Save. Now enter a P to set the file type as a program. Now enter a file name, in our case we enter P1. Now hit Execute. This should save the measurement program in the user file P1. Note the disk write LED flickering. Go back to the main menu. Press User Catalog. We confirm the new program file stored on our SD card is present. Let's ensure we can delete the file. Press Purge. Again we enter a P to set the file type as a program. Now enter the file name, P1. Hit Execute. Perfect. The file has been removed from the SD card. So that's it, we now have an operating 4145A. In the following clips we will cover adjusting the screen, rebuilding the power supply and general usage of this amazing piece of equipment. This completes the clip. I hope you found it informative. Thank you for watching. We will be producing a number of upgrades to this unit, so stay tuned for further clips in the series. Please subscribe, like and comment. Your feedback is important.